去到第22條咧，有關於同一個科學探究嘅。不過今次我哋要諗嘅咧就係有關於光源嘅位置啦。有兩個學生咧喺度拗，其實咧嗰啲植物咧擺咗喺一個完整嘅培養液啊，或者欠缺鎂質嘅培養液啦，OK 冇問題嘅，係盞燈啫。點擺好咧？有個學生就話啦，喂，好似方法一咁樣，將盞燈咧擺喺啲幼苗嘅左邊啦。而另一個學生咧就話啦，唔係，應該要擺盞燈咧喺啲幼苗嘅正上方。嗱，呢個方法2啦。咁而家咧，我想講多一樣嘢，就係喺呢個方法1、2當中咧，咁我俾多個命名佢哋啦。呢個咧叫1A，呢個咧叫1B，呢個咧叫2A，呢個咧叫2B 咁樣款啦。嗱，以知識別嘅啫，因為陣間咧，我想做一個比較啊。咁而家咧，成個實驗啦，就係考翻，喂，實驗設計啦，係盞燈擺邊咧，有冇學問咧？當中啦，亦都考我哋咩叫公平測試啦，控制變項有啲咩嘢你需要控制嘅咧，亦都考埋自變項啦。咁好快啦，又溫書啦。科學家咧往往會通過實驗嚟驗證假説係咪成立，而實驗嘅結果咧通常都係受到多個因素或者變量所影響嘅。而我哋要確保一個實驗係公平測試，我哋就只會改變我哋所探索嘅因素，而其他嘅因素應該保持不變嘅。所以我哋改變嘅應該係我哋嘅 IV 自變項，而其他變量應該保持不變，就係控制變項，對不對？咁而家題目啦就問翻啦，喂，以下咧有關於方法1同2咧，邊一句陳述係正確嘅喎？嗱，喺呢度 A、B、C、D 4句咧，我有樣嘢想提大家嘅，就係佢哋嘅句式都係講緊方法1或者方法2邊個可取啲啊？因為嗱，留意下，因為之後嗰句説話，佢係咪真係嗰個原因？大家要諗真啲嘅就係嗰個 because 後面嗰句説話，即係個因為後面嗰句説話，係咪真係咁真確先？因為如果後面嗰句唔真確嘅話咧，其實個因果關係就錯咗噶啦嘛，係咪？咁我哋就嚟做一擊破咯喎。A 句就講啦，方法1係可取嘅，因為佢能夠模仿到自然嘅環境。就係總係有啲植物咧係會近啲個光源㗎，係喎嗱，模仿自然環境咧，令我諗起咧，以前有條題目咧，我哋係模仿人嘅消化㗎喎，咩擺喺37度啊，跟住加啲酸，跟住再加啲酶啊，跟住又加啲鹼中和佢，跟住再加翻啲酶落去啊，諸如此類。係咯，模仿自然環境係啱噶啦，係真係噶嘛，總係有啲植物係近光，總係有啲植物係遠離個光線噶嘛，好正確啊，好正常啊。我哋就諗真啲啦，係冇錯。雖然喺自然環境底下咧，啲植物係會有一啲係接收多啲光，有啲接收少啲光。一棵樹啊，樹頂同樹底接收嘅光線都唔同啦。冇錯嘅。不過作為一個對照實驗嘅目的，就唔一定係攞嚟模擬一個可變嘅自然環境。嗱，我唔係淨係講下 1B 喎，1B 係對照實驗嚟噶嘛，1A 咧就係實驗裝置嚟噶嘛，即係呢兩者啊係要做比較噶嘛，係咪？但係啦，我要做一個可以俾我對照到嘅實驗，我唔一定要模擬一個自然環境嘅，最緊要嘅係我能夠公平測試到單一嘅自變量。咁啊，1A 同 1B 其實啦，係有機會受挑戰嘅喎，你諗下，我當啦呢兩棵就真係近光嘅，而後面嗰兩棵咧就遠離光嘅。嗱，約略俾個數字佢哋先啦，係咪？前面咧又係叫1、2、3、4，呢度咧又係叫1、2、3、4。OK，咁阿3同阿4咧都係屬於啦接收得唔夠光嘅，係咪？如果俾我發現喺1A 嘅植物當中，阿3同阿4都生得唔好咧，你點解釋啊？係嘛？唔通你我知我記得啊，我溫過書啊，因為咧光咧對於棵植物攞嚟做葉綠素咧，製造葉綠素都好緊要噶，所以阿3、阿4吸唔到光，佢咪製造唔夠葉綠素咯？喂，咁關唔關個鎂質事啊？我又倒翻轉頭又問你啦，咁你企咗喺度噶咯喎？因為嚴格嚟講，1A 同 1B 咧，其實佢係多過一個 IV 噶，一來啦。溶液入面有冇欠缺鎂質啦？二來啦，個光啊，個照亮程度啊，自己呢度1、2、3、4，哪怕喺個裝置入面自己嘅呢4棵嘢咧，佢哋接收嘅光度都係唔同噶。 又慢慢俾人挑戰，俾人蹂躪到唔知幾時啦。所以 A 啦就要 say goodbye。跟住去到 B 咯，佢話阿一同阿二咧同樣咁可取嘅，因為咧無論係裝置一 A 一 B 定係裝置二 A 二 B 啦，佢哋都係用緊4棵嘅幼苗啊嘛。好公平㗎啦，呢度有4棵，呢度有4棵，呢度有4棵，呢度有4棵，係嘛？冇所謂啦，甚至乎阿二自己又係4棵，阿一自己又係4棵。你要明白到，喂，用4棵幼苗，樣本數量一樣呢件事梗㗎啦 ，CV 嚟㗎嘛。你冇理由啦，哎呀，左手邊咧就用4棵嘢，係咪啊？右手邊呢個對照實驗咧，我用9棵嘢。喂，9棵植物啊，9棵幼苗啊，養分嘅需求都高啲啦，係咪啊？爭養分都爭崩頭啦，生得衰唔奇噶喎，因為啲養分要攤分俾4棵或者9棵嘢噶嘛，係咪？咁所以用4棵。焗梗噶啦，一定係噶啦。不過而家係講緊盞燈擺邊啊嘛。我哋成個實驗設計嘅關鍵就係究竟呢個測試比較嘅時候公唔公平啊嘛。呼應翻 A 嘅選項，個光嘅因素已經唔公平啦，係咪？所以 B 咧又 say goodbye 咯。然後啦，去到 C 啦，佢就話阿一同阿二同樣咁可取嘅，因為佢哋兩個都係公平測試，即係話1A 1B 自己比較又係公平測試，2A 2B 自己比較又係公平測試，你就要諗真啲啦。方法2的確係公平測試嚟嘅，因為啦實驗裝置有晒所有養分，對照裝置冇咗鎂質，其他養分都有嘅，而個光照嘅程度距離大致上係一樣嘅。方法2嘅比較真係公平嘅，但係方法1咧，喂，咪又係嗰句咯。阿一同阿二收得多啲光，阿3同阿4收得少啲光，你又俾人挑戰緊啦，係咪？所以其實方法1咧，佢係咪一個公平嘅比較咧？唔係嚟嘅，所以咧 C 又 say goodbye。咁去到 D 啦，自不然就係最後答案啦。佢就講啦，方法2咧係可取嘅。咁啊，因為佢能夠減少到同一組入面嘅嗰4棵幼苗咧嘅環境差異啊。其實個環境差異係乜嘢啊？咪就係個光源咯。大家擺喺正上方，佢哋所接收嘅光源大致上應該係一致嘅，係相同嘅。即係話我哋唯一嘅自變項所測試嘅變量就係佢哋吸唔吸收得足夠嘅鎂質。而唔係光嘅條件，就唔似方法1啦。方法1咧喺1、2呢兩棵，吸多啲光啦，開心啲啦。但係3、4呢兩棵，喂，吸得唔夠光噶喎，又係嗰句啦，又俾人挑戰到體無完膚。咁所以大家啦有關於過往嘅自變項啊、CV 啊嗰啲題目咧，咁啊快手睇下片溫下書咯噃。好，題目解完啦，有一個問題問下大家嘅。嗱，阿一同阿二呢兩個方法，咁啊盞燈擺嘅位置唔同啦，係咪？我想問下大家咧，如果我將盞燈擺喺個幼苗上面啊，即係呢個第2個方法咧，係能夠提升咗個實驗嘅乜嘢咧？嗱，有嗰啲咩準確性啊、可靠性啊、真確性啊，係嘛 ？accuracy、reliability 同埋 validity。你試下喺留言區留低你嘅答案。擺盞燈喺樓上，擺盞燈喺個幼苗上面，係提升咗個實驗嘅邊一個層面呢？ Question 22 We studied the same scientific investigation and 2 students argue about the position of the light source. Student P proposed that put the light source on the left-hand side of the ceiling, which is the method 1, and student Q argued to put the light source at the top of the ceiling, which is the method 2. And the question asks us which of the following statement about these two methods used is correct. So the question is checking us the concept about the experiment design, fair test, and the control variables. Surely also about the independent variable as well. So let's have a quick revision. Scientists test hypotheses by doing experiment, and there are usually many factors called variable affecting the result of an experiment. To ensure an experiment is a fair test, scientists only change the factor under investigation and keep all other factors the same. So the only factor we change which is under investigation is the IV, independent variable, and keep all other factors are the same. They are the control variable, right? And before we talk about the option, I would like to remind you one thing about all statements. You can see that because, and because. So you really need to think about that. So you need to be aware that the statement behind the terms because, is it really valid? Is it really true? Because it will affect the meaning of the whole statement. So let's take a look at the answer one by one. Option A, method 1 is preferred because it simulates the natural environment that some plants can be closer to the light source. So I give you the labels first. Method 1, and we have 1A, 1B, and then we have 2A and 2B. So for all the setup A, they are the experimental setup, and for the all setup B, they are the control setup. So let's take a look at setup 1A, 1B. The plants in nature might have different light access. That's correct. However, for the controlled experiment, the goal is not necessarily to simulate a variable natural environment, but to test a single variable, which is the independent variable, fairly. So some students, they pick up this choice because they recall the experiment that in the past we have the past paper to talking about the in vitro digestion. Oh, we need to put the test tube in the 37 degrees Celsius water bath and then add some acid and then add the enzyme and then add the alkali and then add the enzyme again, whatever. We try to simulate the body condition for digestion, right? However, for the fair test, what we need to do is not to simulate the natural environment, the body condition, but make sure it is a fair test. We only change one single variable. It's fine. But you can see that for setup 1A, 1B, maybe for these two plants, they are really close to the light. But for the other two plants, the steelings, they are a bit away from the light. So our result will be challenged. Some people will ask that, for the stealing, let's say the number 1, 2, 3, 4, 1, 2, 3, 4. What about 3 and 4? They really show the poor growth. So what happened? Does it mean that actually magnesium is nothing important? Because in the complete culture solution, 3 and 4 may not grow that well. And then, I know the reason, Mr. Leung. I do the revision before. Because light is also necessary for the chlorophyll synthesis. It's correct. So, how can you confirm that the poor growth is really caused by the magnesium deficiency? No, you cannot. Because in setup 1A and 1B, actually, there are two independent variables. One is about the culture solution, magnesium deficiency or not, and the second independent variable is about the light intensity received by the steelings. So option A is wrong. And then option B, method 1 and 2 are equally preferred because both groups of the stealing are having the same sampling size. 4 stealing, 4 stealing, 4 stealing, 4 stealing. So it seems like correct, Mr. Leung. But I can tell you that although both methods use the same sampling size, but you know that the sampling size must be controlled for stealings. Because you see that 4 stealings, 4 stealings. So what about in the setup 1B or 2B? I make it 9 stealings, 9 stealings. Is it fair? 4 to 9, 4 to 9. No. Because there are more stealings in the setup B, the control setup. So there is more rigorous competition among the stealing. For what? For the minerals. So what if in setup B, 1B or 2B, they show the poor growth, the stealing, they show the poor growth. How can you understand that? Oh, because there is not enough magnesium. I can argue with you that the magnesium may not be that necessary, but there are so many plants stealing to compete with each other. Therefore, they do not get sufficient amount of minerals. Therefore, there is poor growth. It also makes sense. I challenge your result. So how can you fight back? Sorry, you cannot. So the key factor in the experimental design here should be the fairness of the test. So the sampling size must be for stealing, should be all the same. But it doesn't mean that method 1 and 2, they are equally preferred. Option B, say goodbye. And then for option C, method 1 and 2 are equally preferred because they are both fair tests. No, because method 2 is really fair test, I agree. In method 2, for the light intensity received by the stealing, almost the same. It's good, well controlled. And then one setup, complete culture solution. And the control setup, magnesium deficient culture solution, that's the IV, right? So in setup 2A and 2B, there is only one IV. So it is a fair test. However, for the setup 1, you can see that for the stealing 1 and 2, they receive more light. And the stealing 3 and 4, they receive less light. Therefore, the light intensity is another IV. So there are 2 IVs between setup 1A and 1B. Is it fair test? Sorry, it's not. So option C, say goodbye. Finally, option D is the answer, right? So it says that method 2 is preferred because it reduces the environmental variation faced by the 4 stealing within the same group. What is the environmental variation? Is the light source, the light intensity, right? We ensure that all stealing in a single experiment group receive approximately the same light intensity. They can receive almost the same light intensity. So only the tested variable, which is the presence of the magnesium or not, should differ between the complete and magnesium deficiency solution, but not the light condition. So it is a fair test. And put the light at the top of the stealing, it can reduce the environmental variation faced by the 4 stealings. So in the past, there are different questions about the control variable, independent variable. So watch video for the revision. So after explaining the question, I want to ask you one more question. So method 1, I put the light on the left side of the ceiling. Method 2, I put the light at the top of the ceiling. So I want to focus on method 2. By placing the light at the top of the ceilings can increase which aspects of the investigation? Accuracy, reliability, and the validity of the investigation. Leave your answer in the comment section and let's see your concept is clear or not.